decision tree. A tree kind of a structure which helps us to make some decisions out of the data, which helps to classify the data. And we are going to see the classification using decision tree. Okay. So here there is an example which is given. Okay, so we'll follow a different example, so it will be easy to understand. So where I have already said it's a decision tree, it's a tree kind of a structure which helps to make a decision. So now, so I'm a bank manager, okay, so for credit risk system or credit cards division. So take a credit card division, okay. So what happens, my business case here is, so it's a credit card company where I have 10 customers. In the 10 customers, I have 2 sets of customers, 5 is going to be profitable and 5 which is going to be unprofitable customers. Out of profitable customer, how do you determine a profitable customer? Whenever people have a credit card, buys, shops for the product, and then they don't do a payment on right time, and they pay on late payment fees plus interest, all those things, customers which is paying, those customers are called profitable customer. So unprofitable customers are the customers who buy the products but they pay on time. So for them, having them as a kind of a customer in the bank, which does not going to bring any profit to the bank. So there is 2 types of customers which we have seen. Unprofitable customers are not kind of adding any value to the bank, but the profitable customers are adding more value to the bank. Now, as a kind of a decision authority person, I have a kind of a budget for marketing the credit card and get the customers to buy the credit card, okay? But I have a limited budget. So with that limited budget, what I want is like, I want to target the audience and find out the potential of becoming them a profitable customers to the bank. Only those customers I want to target and sell the credit card. If I have 100 customers, 100 customers will not be a potential customers, will be a profitable to the bank. Out of 100, only 50 will be there. Out of 50, if I target, definitely I can sell 10 cards and they will also bring revenue to the bank. How do I find from a huge crowd of people who will be my profitable customer and potential customers to buy the credit card? Okay, so that is my requirement. So those things I need to classify whether the customer will be a profitable customer or unprofitable customer. Based on the classification, whether the customer is profitable, then only I will go and market my credit card. So now I want to find out whether the customer will be profitable or not, if the business requirement is clear. Okay. So now, with that understanding, any of the bank will have already the history data. The bank already will have the history data about their customer details. So now let us take 36, the customer ID, age and their gender and their marital status, number of credit cards and profitability. So what happens here, the customer ID, what is the age of a customer, what is the gender of the customer, what is the marital status, number of credit cards and profitable or not. So this data is already available in the bank. So now I want to train my system in such a way to find out what makes a customer profitable and what makes a customer not profitable. So that's what I want to find out. So when I don't know what I have to do with the data, where do I start with the data? I will start with the customer ID, I will start with the age, I will start with the gender, marital status or number of credit card. Okay, where do I start it? I don't know any answer. I don't have any clue. In such situation, it is advised to go for decision tree. Decision tree internally has an mechanism or an intelligent system to find out where to start from, because where to start from is a very key for a data science activities. Whether I have to start from either of the columns, that is important. Which has a majority of weightage, that is important. Out of all the columns in the dataset, which column has a majority of weightage which is contributing for the profitable or unprofitable, that I don't know. So that I'm going to apply a decision tree which internally takes care of it. I'll be starting with a few columns and I'll be explaining why. So there will be a lot of questions will be raised in your mind why this is. So that why I will answer at the end of my explanation. Okay. So now with this I'm going to do a tree kind of a mechanism. What is a tree? Which contains a root and which contains a kind of a leaves or a roots. The bottom is going to be a roof and rest of the thing is going to be a child or leaf. So this, if you look at, it's going to be a tree kind of a structure. You should look from the reverse side, then you will see like a tree kind of a structure. Okay, so that's the reason it's called decision tree. So out of this data set, total 5 customers are profitable and 5 customers are unprofitable. So what is the profitability ratio? 50%. Out of 10, 5 is profitable and 5 is not profitable. So it's going to be 50% of customers are profitable. So when we start splitting the data set between age, split the data set into 2 sets. One is age greater than 35 and one is age lesser than 35. If you take lesser than 30, greater than 35, there will be total 6 customers will fall under this category, greater than 35. Out of 6 customers, 4 are profitable and 2 are unprofitable. Okay, out of 6, 4 are profitable and 2 are unprofitable. So the profitability ratio is going to be 66%. Okay, 66%. It's going to be 1/3 of the customer is going to be profitable. And out of the age which is lesser than 35, total population, 1 customer is going to be profitable, 3 customers are going to be unprofitable, which will be 25% of the customer is profitable. So this channel, if you follow this route, we will not get the accuracy result because only 1 profitable is there. It will be stopped at this point. Why? Lot of whys will be there. I will answer all those things. So further, if you split into the marital status, married and single, out of this 6 records, 4 will be married and 2 will be unmarried. So out of 4% are profitable, 0 is unprofitable. So 100% are profitable, here 0% are profitable. So what is my final conclusion? How do I determine whether the customer will be profitable or not? What you can get out of this data? So whenever any new customer is coming, so 11th customer is coming, okay? What will be the classification outcome? Okay, so this is what we are going to predict. So this will be predicted based upon the decision tree learnings. It will be a profitable customer. Okay, so now we'll come to a lot of whys. So first why can be why the splitting is based upon age. Why not it's split based upon a marital status or gender? Okay, so this is a thumb rule which is called I will not decide on what splitting it has to do. The decided authority will be given to internally by decision tree. On what basis it is deciding? It is deciding based upon a medium called information theory. It is called information gain theory or Shannon entropy theory. What are the meaning of it? Out of all the columns, out of all the variables, that is the independent variable, if I follow which route, if I follow which column, I will get the maximum result set and it will reach to the leaf node till to the final stage of node it will reach. So that calculation will be done internally by a decision tree, and then by that column only it starts splitting. Okay, that is the reason it is called age and greater than 35 and lesser than 35. How it is deciding it's greater than 35 and lesser than 35? It will be decided based upon the value spread in that particular column, and it categorizes into two sets. Okay, if it's a numerical, it will categorize into two sets. If it's a categorical variable, that is a text data, more than two categorical unique data, that much split will be happening on the tree. Okay, and then why you stopped here? Why not you proceeded further? What is my end result? I want to identify the profitability. The profitability here it becomes 1, which means I cannot move further on this. I will not get any results out of it. So that is the reason this node is stopped. Why you stopped here? Why not proceed further? Whenever you don't have a further column to split, then you will be stopping the node. And whenever you don't have a further class labels to split, because here what are the two class labels we have? Target variables profitable, unprofitable. So it is now unprofitable is 0. Okay, unprofitable is 0. So we don't have another class variable to split further. So that is the reason this node has been stopped. Similar case over here, that is the reason it stopped. Okay. The entire internal operations will be done by the decision tree algorithm, where you don't need to do it. So this calculation is purely depends upon the information gain theorem. Got it? So lot of why I have answered. Apart from that, if you have any whys, let me know. So do we specify the dimension it need to build the tree? No. We will only specify till what level of node it can go down. So for example, in a tree you have 5 branches. So go till to 4 branches and stop it there. So that level you can specify. We are going to see that. Okay. We are going to see the example. So this is the decision tree only. Okay. Fine, Arun. We will specify the depth of the tree. What level of depth it can go. Because for some data sets it will go 100 or 200. We cannot control that. We'll say it's a random. Okay. We'll start with 1 by 1. So for example, I say 5. See the output. If you're not getting accuracy, increase or decrease to the output. Increase or decrease to the output. Fine. So all it's a trial and error method only. So it keeps on, you have to increase or decrease the tree to get a better accuracy. We have 100% accuracy here, so why don't need to continue? So I didn't get that question, Arun. Sorry for that. So what is that? Can you rephrase it, please? So in this example, yes, we got 100%. You mean this one, right? 100%. So we don't need to continue. No. It does not mean like that. Okay. So that way I explained, right? Why we are stopping at this point. When you don't have a further class variable to split, because here the class variable. Okay, got it. So here we have not splitted because of 100%. We have not stopped because of 100%, because there is no further class variable to split. You see that? The class variable is unique now. It does not have any class variable to split. So that is the reason we have stopped. So why generate credit card cool was not considered? So I have answered this, right, Sundar. It is of information theory. So I have taken this, okay, for an example, but automatically the which column it has to pick for analysis will be decided by the information theory, which will be a part of decision tree. Okay, so you can take it. You can take that as well. That's not a problem. So for explanation, I have taken this. That's all. If you take, it will be splitting further. Okay, so it does not use a number of credit cards because it is not having enough value to spread. No, it is a unique, okay, number of credit cards, right? So we can take that as well, but a tree will fall in a certain directions. Okay, so the root will be the base. Out of the base, it starts spreading the nodes. Nodes, when I say branches. So while it's splitting the branches, which branch will get the maximum kind of a outcome, or till it can reach to a leaf node? So that column will be chosen. For an explanation purposes, I have chosen an H only for an explanation purposes. You can choose a different column as well and try out the tree. Fine, Besar? Can you please show the same in decision tree? This is the decision tree, Madhu. Okay, we specify the depth of the tree. Yes, we do it. I'll show you how we know the depth of the tree. It's an iterative approach. System will have a default one. You can increase or decrease. It's up to the accuracy what we want. So if you work tweaking the model until we get the best results on testing, 30% of data. Yes, at least you should get above 70% or near to 70%. That is acceptable values. Fine. Yes, in R we are going to see that. Okay, so this is an example for your understanding how a decision tree will work. We'll be seeing the examples. So let me know if I missed any questions. So there are certain terms which is available in decision tree, where the top node is called the root node. Under that, whenever the further splitting will be happening, that is called a splitting. And whenever there is a condition, decision, if yes or no condition, if yes, go into the root, if no, go into the root, it's called the decision node. And final node is going to be the terminal. And a decision tree which has a further levels of child, which is called the subtree. And grafting is something, if you don't get a particular output, you can cut the tree, cut the nodes, and bring the output to a certain level to get the accuracy. So that grafting is called the increase or decrease the depth of the tree. Got it? So any queries or any doubt in understanding the logic, that's all. Only the logic. How do we apply in R? We are going to see that. Only the logic, how it is working. Is that clear? Asha? Satyam? Surab? Surab, all fine? I didn't see any queries from you. Is it all clear? Shinil? So any type of restriction of independent variables we can have. As such, there is no restriction, but okay, factor variables you cannot have it. Factor variables also you can have it. Okay. Continuous variables also you can have it, but the only thing is like you will be getting a result set which will show an incorrect, or the accuracy will be less. It will not throw any error saying you cannot have it and all. You can have it, continuous you can have it, categorically you can have it. So categorically equal to factors over in R. Okay, you can have it, but the accuracy might vary. Factors and categorical variables, when I say categorical, it's also factors. So continuous variables, when you have a continuous, categorizing that variables, that will be very much important to get a better accuracy. Fine, Suras? Okay. It's just a sequence of variables. Okay, what is continuous variable? It's a sequence of variables, sequence of values. Fine, Basar? So this is what the learning, a loan application, medical diagnostic, prediction, any speech objection. object recognition, all is going to be a classification. We can apply decision tree. So out of decision tree, we have the types of node: root node, branch node, leaf node. So when I say branch node is going to be a decision node, okay, leaf node is going to be a terminal node. Leaf node is going to be a terminal node, and branch node is going to be a decision node. So these are the nodes which is we represent in a decision tree. And all decision tree will be looks like this: true or false. Based on the decision, it goes into further routes. So wherever you see a decision tree is true or false, and always you will see two things. So it does not mean only two things it can split. If you have a categorical variable here, the number of unique categorical variable in that particular column, that much terminal nodes it will split. Okay, you should be clear in that. So number of categorical unique categorical variable, that much terminal nodes it will split. So we'll see that. So this is some of example of decision tree for weather identification. Some of the examples. Okay. So it is, if you look at here, the same thing is split into three things: sunny, cloudy, and rainy. Okay. So this three things is going to be categorical variable. So what I said is like a uniqueness of a categorical variable, that much split will be happening when you apply a decision on that particular column. So this example is to find out whether today it will rain, we can go and play or not. Okay, so that's a kind of identification. So based on the weather condition, it splits further data set and says whether you can play or don't play. So that's a kind of identification. It's similar like what we have seen with whether it's a profitable or unprofitable customers. Okay, what is true or false? The record greater than 37, 35, true. False means go here. Correct, Sundar? Boolean condition, yes or no, true or false. Decision, decision in flowchart, right? So it's a true or false condition, yes or no condition. Same like this. If a particular row is greater than 35, yes, go in this route, no, go in this route. Clear? Okay. So this is how a tree will look like when you build a decision tree out of it. So based on the tree only we'll infer what will be the outcome and what channel the tree has followed to get the result set. So now we have another example. It seems like what we have seen in the bank example. Similarly like you, okay. So we have a different records: age, income, student, credit rating, whether he will buy the customer or not. Okay, max a customer or not. So that's the question. So the max a tree can have only two subtrees. No, not a two subtrees. Depends upon the uniqueness of categorical variable. So it's a numerical, only two. If it's a categorical variable, when I say categorical, like good, better, best, three categories are there. So there will be three terminal nodes will be available. Got it, Sundar? I'll show you in the example. I'll show you. Okay, few minutes. So my requirement is to find out whether the candidate will buy the computer or not. That's my requirement. So if you look at, there is a categories of age also available: less than or equal to 30, greater than between 31 to 40, and greater than 40. Likewise, we have a different categories. Okay. So now, if you look at the student is a root node, now we're splitting the data further to that. Yes or no. It's same like example what we have seen. So we'll be moving fast on in this one. So just stop me if you don't understand. Okay. So first split is going to be whether student yes or no. Why? First of all, I'm splitting based on the student yes or no. It's, as I said, it's purely depends upon the decision tree based on information gain theorem. On what basis if it splits, it will get till to the child, that is the final level, and the accuracy will be more. So that calculation will be done by information gain theorem. The theory we will see it in another couple of minutes. Okay. So then further I split it by the income. Can you see it, Sundar? Here I have three things. So low, medium, high is not a numerical figure. It's a categorical variable. Okay. It's split into three childs. Do you see that? Okay. So based on the number of categorical variable, that split will be happening. So if it's a no, and based on the income, high and medium, it's further split into this. Then based on the high and the medium, so if you look at why I'm stopping here, can anyone answer? Why this node is stopped? Why this node is stopped? It is not proceeding further. Any answers? No more generic or iteration because it cannot be split further. Yes, the uniqueness of the class variable is unique. Do you see that, Sundar? The class variables is unique. So further we cannot split. What is the thumb rule? Whenever you don't have further columns to split, or you finally achieve a uniqueness in the class variable, that is a target variable. So at that point you have to stop. That point the tree will stop. It will not proceed further. Okay. Excellent answer, Arun. Excellent, Anup. Good. Okay. So now, similarly, the further nodes are available that will be splitted. So now, I'm going to split based upon their credit rating, fair or excellent, fair or excellent. Likewise, here in this area, the split is going to become on the age. So it is not restricted for all the nodes, the split should be same. It is not like that. In that particular node, what will be the split, that will be decided. So here further split, here yes or no, yes, yes, and here yes or no, here yes, no, 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 yes. So if you have it, there are a lot of nodes which is reaching the final stage, no, yes, yes. So which cannot be splitted further. That's the meaning of it. So here, if it's a student and the income is medium or high, they will buy the computer. Here, if they are not student and the income is high and the age is lesser than 30, they will not buy a customer. They will not buy a computer. So in this case, if it's a student, if it's not a student and the income is medium and the age is between 31 and 40, they will buy a computer. That's a kind of a interpretation or inference we have to make out of this data. Further we do that, finally we achieve this output. So can you see the tree? Can you get the output from this tree when a student will buy a computer or not? Can we able to identify from this? Okay, Arun, Anup, Asha. So this is how the tree will look like in R. So this inference is only will let us to know whether they will buy the computer or not. No also present. Did you see that, Arun? No also present. Okay. So there are no's also available in this, which will tell the student will not buy the computer. So internally the rule will be built like this, but we will not see the rules. Okay. Where if there is no student and the income is high and the age is lesser than 30, buys computer no. So this is going to be a classification rule. Internally the tree will be building it. Finally we'll get only the result set. So now, previously I have followed a route of student yes or no. If you follow a different route, start from income. Another route, another kind of a route you are going to follow to reach the output. Previously we have followed a student yes or no route. Now we are following the income route. If we follow the income route, the same kind of steps. Finally, we arrive an output. Is that clear between two things? It's only to show you if you follow a different route. But internally, the route will be decided by the decision tree of which route it has to follow based on the information theory. So far, we have not seen the information theory. So that's the reason I've said we'll follow a different route to get the output. Okay. And this route will be internally decided by the decision tree algorithm. Clear? Yes. It may optimize, it may not optimize. Fine, Arun? That only depends upon the iterations. Clear? How well you are generalizing your data, that is important. So now, so this is also same thing. Now, which tree to choose? Which column it has to choose to split the nodes and to proceed further to get the output. Okay, so that we said it's a decision tree will be decided based upon the information gain. What is information gain? Okay, so there is a question from Besa. So any levels of tree we can have a split across the different columns. We cannot choose it. It will be chosen by the tree only. Okay. If you are not getting a tree accurate, so you have to treat the data to make the tree to read from a generalized data set. Fine. So if the data is very huge, the tree may go huge. Yes. No, you should not. That's the reason I said it's a 9. Till you specify a number of branches, based on the number of branches, it will recalculate from which column it has to start. Fine, no? And you should not use 200 columns for a tree and all. Okay. The maximum, if you use around 15 to 20 columns, that much you have to use it. Clear? No, if a column is used in one level, cannot be used in another levels. That part will be removed for the futures to be pending for making the node. Clear? If a particular column is used for one splitting, that column will not be available below for further splitting. You are crossing that node, right? So it will not be available. You crossed that stage. You cannot come back and use it for another stage. Besa, this is clear? Okay. So information gain is based upon the decrease in entropy. Entropy means the final stage it reaches to that 0 level. So when I say 0 level, it is this stage. This is a 0, which cannot be splitted further. So after data set is split on attribute, constructing a decision tree, it's all about finding an attribute that returns the highest information gain. That is the most homogeneous branches. Most homogeneous branches is equal to single value. If I choose which column, I will get an homogeneous branch, which means the final child will be uniqueness. So it will not have further splitting. That is called homogeneous branches. So that will be decided by information gain. And it also called as Shannon entropy theorem. It's also called as Shannon entropy theorem. Which column if I choose, the output will be better and the entropy will be 0. If the sample is completely homogeneous, entropy is 0, and if the sample is equally divided, it has an entropy of 1. So that column splitting only will be chosen for the splitting. And this information gain will be applied at each level of splitting. It not only a one level of splitting, it will be applied at each level of splitting. The same if you do with the machine learning with R, it's simple. If the same if you do with the machine learning with Python, you have to write almost 200 to 300 lines of code to do this. Okay, but it's mainly for R&D purpose. So now if we apply the information gain theorem on the student yes or no splitting, what will be the gain we'll be getting? So this is the information theorem formula, but actually we don't need to do anything. It's only for your understanding. Formulas in R are fixed. which is internally used, which is decided by the proved methods. Some of the formula which will be difficult in understanding in relevance to our logical aspect, but that is how the formula is been framed. Okay, when we really take the data and apply to the formula, definitely we'll get the correct results. When we apply logically to the formula, sometimes it might be confusing. Okay, so information gain theorem for P and N. So this is the inputs, where 9 is going to be the number of we take this result set. Okay, so 1, 2, 3, 4, 5, 6, 7. 1, 2, 3. What is the number of records? 14 records. Okay, total out of 14 records. Copy this. Okay, so 9 divided by 9 plus 5, total number of 14 records, out of which the number of students 1, 2, 3, 4, 5, 6, 7. Based on students, right? One, 2, 3, 4, 5, 6, 7. Okay, take this. Okay, so if you look at here, out of no, it will be 1, 2, 3, 4, 5, 6, 7. 3, 6, 7, and here it is going to be how many records? No, and here it's going to be 3, 6, 7. So just a minute. Okay, so this is the one. Okay. So where if you look at, it's student yes and no. Okay. So 6 and 3. Okay. Is that clear? It's something, it's, let me minimize it. Okay. 1, 2, 3 and 4, and here it's going to be 3. Okay. 4 and 3, and S is going to be 6 and 1. So it will be 1, 2, 3, 4, 5, 6 and 1. So if a student is yes, it will be 6. That is a possibility of buying yes or no. That is 6 will be yes. It should not be P, it should be yes. Okay, yes or no. And when the student is no, it will be like this. Okay, where 1, 2, 3, 4 are no, and 3 customers is going to 3 student. Out of 3% in this chain, it is going to be 3 and 4. Is it clear? Okay. So out of which, if you take, clear Arun, and so as Madhu, okay. So if you take this channel, we are going to get this result set. So out of which, if you take 6 plus 1 divided by total number of records will be 14. Okay, into that the probable, this value which we got over here is 5.91 for student is yes, and similarly for no we got 0.97. When we multiply with this and do this calculations, we will be getting 0.155. That is the gain of a student. 0.155 is going to be a very good entropy. As I said, if you follow the chain of splitting the data set based upon the student yes or no. Okay, is that clear? Okay. Yes, it should be close to 1. Close to 1. Next result set, yeah, it's a good entropy. Next entropy, if you choose by the next split, that is based on income, the same kind of principles. When you start based on income lower I, the same applicable, 3, 2, 1 and 1, 0, 0, 1, 0, 0. So likewise, if you start splitting based upon the income, age and credit rating, all those things. So if you look at 0.N5, which is closest to 2, which is having the very good entropy level when compared to the other things. Okay. So out of this, what we choose is to start with 0.15 with student yes or no. We get the maximum level of accuracy. So how this has been determined, when I start with age and then split by this, 0.24 is accuracy level and 0.916. Finally, do you see we have 1 year? Can you see it, Arun? No. Age means when you start splitting, the final thing it has to reach 1, where it does not have a further split. So that is a chain of information theory calculation. The gain will be based upon each and every start point. So when it starts from student, further it will apply information gain on other set of columns. Further it will apply a gain on information gain on other set of columns. Finally, it should reach 1 at the bottom, which means the homogeneous result set you will be getting. when I start from student. That's the meaning of it. Clear? Clear, Arun, Anup, Sundar? System will repeat for all the columns. Right. It will repeat from all the columns. Okay. Students with low income scores, phase is osmos optimum. Yes. Okay. So this, all the calculations will be internally. We don't need to calculate anything externally. So just all this understanding what we did is a one line of code. That's all. What all this understanding what we did is a one line of a code which internally the decision tree does. Fine. So we'll do a practical, then we'll come back to this question. Okay, we'll finish this. So which node in decision tree correspond to the best predictor? Root, branch, or leaf node? Root node. Okay. So root is only decides on which split it has to do. Okay. Which node represents the decision taken after computing all attributes? It's leaf node. Excellent. Okay. So now we'll see an examples. Okay. So this is the healthcare datasets where the target variable is going to be the class variables. Always remember, can be target dependent or class variables or class labels. So I'm going to predict yes or no, whether the patient will get diabetes or not. That's what I'm going to find out. If I feed all this data set for the future patient which is coming to the hospital, so I'm going to predict whether they going to get likelihood to get the diabetes or not. So this is my data set which is already available in my hospital. So with that I'm going to train the data set to learn the system and to predict for the future data set. If the requirement is clear. So some of the healthcare terminology which is available: number of times pregnant, plasma glucose concentration, diastolic blood pressure, tricep skin fold thickness. Likewise, all are diabetes or healthcare terminologies. Okay. So now we are going to read this data set, train the model, and then we are going to use for prediction. So for decision tree, we have to install a package called rpart. Rpart is used for reading the data and predict using the decision tree model. So now I'm going to set the working directory. So this is for get the directories, what are the files available. So now I'm going to read the file. So if you want to replace the name of the column, you can use it. So the names is to find out the list of names, column names which is present in that particular file. Okay. So strd, which will give you the list of columns which is present. Can everyone see it's called factor variables? Always the class variable should be factor. It should not be numerical or any other variable. For decision tree or classification, always the target variable should be a factor variables. Okay. And other columns that says 9 variables and 768 observations which is present. And what are the data types and what are the data which is spread. All the details you will be getting when you use strd. So attributes of D, which will give you the number of rows which is available in that particular file. So now I am going to use R part. How do we know which package to use in R? It's by practice you'll get it, Madhu. Should it have the same name class variable for the library? No, it can be anything. Where we are going to say which column you have to use for analysis. Can be any name, can be. Okay, name of the columns doesn't matter. Only the data type of the column should be factor variables. Fine, Arun. So now there is one mechanism which I'm going to explain. That is how you have to do here. Okay. Set seed. What it means is we have said you have to take 70% of data, sampled data for training and 30% for testing. Whenever you take a sample data, now I want to use a sample data. Now if I run this, I will get first record is second sample and second record is first sample. So I'm saying get me 2 samples out of 768 records and no replace, no repetitive, and 70% is for first and 30% is for second sample. If the statement is clear, sample statement is clear. Not clear? Okay. Sample, get me 2 samples. First sample is 70%, second sample is 30%. Number of rows of D will be 768. Out of 768 records, get me 2 samples. If there is replace is equal to true, means any repetitive of sample identified, replace it. Fine, Madhu, Suhas? Okay. So now if you look at first record 1, 2 represents the sample ID. First record goes to the second sample, second record goes to the first sample, third first sample. Again if I rerun, do you see the position is changed? Can everyone see it? The sample position is changed. First record is now first sample. Second record is now second sample. So each and every time you run the sample, each and every time it will give random numbers. So in order to fix that random number, because we are going to train and test the system, okay? We are going to train the system. So we need a same set of samples every time, then only we can validate our accuracy of result set. If each and every time it gives a different data for training and sampling, training and testing, it's difficult for us to calculate the accuracy, okay? Right, system is randomly putting the records in 70 and 30 ratio. Yes, randomly, that is called sample. Sample is a random, okay? We are splitting the records into 2 samples, so we are giving 1 sample to train, not to train. We just only taking the data of 70 and 30, that's all. Got it, Arun? Now we are only taking the data, which we'll use for training and testing in future in another 5 minutes, okay? So each and every time if I run, it gives a different number. So which I cannot use that data for my training and testing. So to avoid that, what I'm going to do is like I'm going to use a mechanism called seed. So when I use a seed, set seed, and you can give any integer number, it's not fixed. So always if you run now, it will give the same sample. 1 1 1 1 2 1 1. Okay. If I run again, can you see it? Can everyone see it? Now it's giving the same sample. N number of time if you run, it will give the same sample. Can everyone see that? Sundar, Arun, Anup, Suhas. Okay. So that is the reason I want to set seed. If you don't set the seed, every time it will give different result set. It will be difficult for prediction. So set seed can be any number. So after now I got the data set, out of which all belongs to sample 1, I'm going to give to training, because 1 is 70%. Okay. That number can be anything, any numerical number. Fine, Sundar. And the second sample is going to be the testing, 30% of record. So if I see the data, 513 observation for training, okay, and 255 is for testing. So out of which 768 is our record, right? 513 it went for 70% for training and 255 is for testing. So now we are going to build the decision tree. So any number you can give, any integer number you can give, Arun. It's not a matter. Okay, any integer number. It should be integer. That's all. So now we are going to pass to a model. Can you see this, Arun? You are going to specify the name of the dependent variable. Okay. So which means any column name it can be. It should not be fixed as a particular column name. Any column name followed by the tilde symbol. Right side of the dot, it means except this column, all other columns are independent variable. That's the meaning of it. Except this column, all other columns are independent variable. If you put dot, if you explicitly want to say which column you have to use and you have to ignore certain columns for independent variable, just put the column name with plus symbol. That will be an independent variable. And which data I am going to train, and I need 10 branches. Okay. Yes, it can be a variable also you can give. If you put dot, it means all the column except this. Got it? Except this, all the columns. If you want, you can put the column name as well. Fine, multiple column names. Yes. So this is how you will put it. Do you see it? If you want to put specific column names, we can put specific column names. Okay. Clearer? Okay. So if you put a dot, it means all the column except the right side, that is a dependent column. Rest of the column will be taken for independent variable. If you want to specifically mention which column, for example, 100 columns are there, you don't want to use every column for independent variables. Okay. If you want to explicitly use only a certain columns, you can mention the column name. Fine, Madhu. Okay. So 10 is for 10 branches. Till 10 iterations, 10 branches only it will go. That is called control point. Okay. Till what level? 10 levels only it can go. Beyond that it cannot go. But if it reaches lesser than that also, it will be stopped. That is the maximum it can go. I'm setting. If you want, you can increase or decrease it. Do you always restrict to number of branches, or we let that tree cover itself? It can, if you let the tree to cover, it will still go, keep on identifying it, and finally it reaches to a stage. Then you can start increasing or decreasing. Fine, Suhas? Based on the tree, you can start increasing or decreasing. So now I'm going to apply to the data set. So now I got the model. This is the model. Okay. So which has a lot of variables output, which is difficult to interpret. So what we'll do is like straightly we'll go and plot the tree and find out the outcome. So this is a tree we got. Okay. What will be plasma glucose? So now if you look at the tree, okay. So this is how the tree will look like. So the interpretation will be % plasma glucose, okay, and body mass is lesser than 29.95, okay, and what diabetes pedigree function, what is the percentage, and further splits. So if you go into this route, it says the person is likely to get the diabetes or not. Okay. If you go into this route, the person is will not get the diabetes or not. So that's the meaning of it. Okay. Why age greater than 35 not shown? Okay. So if it means is yes, this is means no. Clear? Clear, Sundar? Yes means go in this route, or no means go in this route. That's the meaning of it. Fine. So in the example I showed, but it will show only one value. Out of this, yes or no, it will be yes or no condition. Okay. How do we do which route to go? We don't need to select which route to go. For your understanding, I'm saying if you see this route, you will know the output. But how do we predict for the future incoming data? I'll show you. Fine, Anu? So now, out of all this column, which column has a majority of data, majority of weightage to split upon? So if you look at here, plasma glucose concentration is 60% and body mass is 33 and age is 23. So that is the reason this column is having a highest weightage when compared to other column. That is the reason it starts splitting by this one. Got it? Plasma glucose is having the highest variable importance. So that is the reason it starts splitting by the plasma glucose. Clear? So now I want to predict for the testing data set. Yes, it's a variable importance, the information gain value only. Yes, you're right. Okay. So now I already have a test data set for which I already know the outcome. So this is my test data set, which is around 200 and some records, where I'm going to predict while you are applying the test data set, it will suppress the dependent variable and only it will give an independent variable to the tree. A class is means we are trying to find out a yes or no kind condition where the outcome will be yes or no. That is why we are giving type is equal to class. It's called class variable is an output. So now if you predict it, okay, I got the predicted result set. Yes or no for each and every record set. How do I evaluate my model? This is the predicted result set and this is the actual result set. So now I'm going to perform a confusion matrix. Confusion matrix will be a confusing. Okay. I'll make it simple for you to understand. So this confusion matrix will give you an accuracy percentage of the model, or as well straightforward you can find the accuracy of the model like this as well. Okay, two method we'll see. So whichever method you follow, that is fine. Okay. Can you show again E to E? So this one. Okay. Okay. So the tree is the outcome of the previous model. Okay. To this model, I'm giving a test data set. While giving the test data set, while it predicting is a method which is a part of our prediction for a decision tree, I'm giving a text data set and type is equal to class, which means the outcome is a class label. When I say class label, it will be a yes or no, good or bad. Likewise, it will be a text value. That is called class label. I'm going to predict that. So if I do this prediction, I'll be getting a predicted result set. Is that clear? Giving a test data and start predicting for the test data. It is mainly to calculate the accuracy of the model. That's the purpose of it. Fine, Madhu? So now I want to find out what is the accuracy of the model. So if I take the difference between the predicted and actual mean, it is giving 31% is the error, which means 69 point something around 100 minus 31%. Around 69% is the accuracy of the model. You got it? So this is not equal to, what is the predicted result set not equal to the actual result set. So which is 31%, which is not equal to. Clear? So the accuracy of the model is 69%. If the same, if you want to do with the confusion matrix to find out what is the level of accuracy, so you will be getting in confusion matrix like this. How do we inference or interpret the confusion matrix? Just see this. Okay. So this side is called the actuals, top side is called the prediction. So I am going to predict no and yes, no and yes. That is my prediction. So which will be termed as 0 and 1. 0 is for no and 1 for yes. So the terminology which is used is called a true negative, which means truly it is identified as negative, it's correctly. And false positive, incorrectly identified as positive, which means out of 168 records, 128 was correctly predicted as negative, which is true, right, it is predicted. Out of 168, 40 was wrongly predicted as positive, which is false positive. Okay, so this is the terms, okay, which you can term as A, B, C, D as well. This is a simple form. And another is like out of 87 records of yes, 40 was predicted correctly. 40 was incorrectly predicted as no. That is called false negatively predicted. And out of which 87, 47 was correctly predicted is called true positive. So out of which, if you want to calculate the accuracy, always sum of true divided by sum of everything. So if you plot with A, B, C, D, if you want to calculate the accuracy of this model, A plus D divided by A plus B plus C plus D, which will be equivalent to 128 plus 47 divided by 128 plus 40 plus 40 plus 47, which will be 69% of accuracy. So the model now gives an accuracy of 69%. Similarly, the same data set will be applying with the different models, and the point should be very, very clear. Always you cannot take a decision by using a single model. You will be applying different sets of classification algorithm, out of which classification algorithm gives a better result set, that we will use for production. Okay. Now we got 69% of accuracy by using the decision model. We will be using a different model and find out which one gives a better result. Is it clear? So finally, the predicted result set, if you want to store it, you can store it. Okay. So now I have a new incoming data which does not have the dependent variable. Can you see it? Without dependent variable. So for this I want to predict. For this I want to predict. So what I do is like I read the data. So Madhu, see this, same I'm explaining here. Read the data, and already we have a model which is built. D3 is the model which we got over here. That model pass the input data set and get the output. So it says for first record diabetes will come, second record diabetes will not come, third record diabetes will come. So that is a prediction. This prediction rule is okay. The model you get from this line, right? Do you see that 45 line? We run a R part. We got the model. Okay. So 69% accuracy is by two ways you can calculate the accuracy of the model. Okay. Either by taking the mean of actual versus prediction differences, you can take the error value. This is called error value. 100 minus this is called the accuracy. 31% is the error. Is that clear, Sundar? 31% is the error. 100 minus 31 is going to be the accuracy. The same you can also do with the confusion matrix. So it gives a value like this. For confusion matrix to interpret, you have to do like this. So this is a confusion matrix table. You have to apply this data here. Okay. When you apply the data here, you will get here 128, 40, 40, 47. Then you have to add all the true divided by all the values of the confusion matrix. This data. You see this data? Madhu, do you see this data? 128, 40. This data you have to apply here. Sundar, is it clear? Madhu? How do we get the data? So just now we have executed this one. If you run this query, you will get this data. Okay? True, total number of true divided by all the values. Fine, Madhu? A plus D divided by A plus B plus C plus D. Fine, Sundar? This is the formula. So both are same only. For your understanding, I have given A plus A, B, C, D. True, sum of true divided by total number of values in the confusion matrix. Clear? Arun, Anup, is that clear? So if it's not clear, get it clarified, please. I said right, confusion matrix will be a little confusing. But always use this sheet what I have given. It will be simple. Very simple. Cross will be true, cross will be false. That's the meaning. Okay? Fine, Sundar. Cross will be true, cross will be false. Yes, confusion matrix will be confusing. But so we have 768 records. So same you apply to a large data set also will be facing the same thing. Is it clear? So if something is unclear, get it clarified, please. So don't go from the class with something not clear. Although is it clear now? It's not confusing. In predict method, type is of type is independent variable. No, type is one more type which is called probability. Instead of yes or no, it will give the probability value. Okay, that's the meaning of type is equal to class. Type of dependent variable. Okay, it's called type of dependent variable. Yeah. So practice it. If you have any doubt, come for the doubt clearing session to get it more clarity. If the clarity is there, if you got how it's working, that's fine. Is information gained by default? Can it be changed to Gini coefficient? Okay, decision tree works by information gain theorem. Okay. Internally, that is Gini coefficient only. Fine to us. Okay. Internal is Gini coefficient only. Okay. Can I get quick yes or no? Is it clear? You have any doubt in understanding? Yes, I will be uploading. Basal. The spreadsheet I have already uploaded. It's already I have sent to the support team to upload it. Okay. Arun, Satyam, Madhu, is it clear? Be frank. If you don't understand, please tell me. I will clarify. I want, end of the day, I want you to understand. Pesad, Satyam, yes, thanks. Suhas, Surab. Sure, I'll do that. Okay. Madhu, clear? Yes, control will be the maximum depth of the tree. Till what level of iteration it can go. Fine, Arun? So here, this is the code. Okay. So this is going to be the dependent variable tilde of dot, which means all other columns. Okay. So where okay. So tilde of dollar symbol, tilde of dot will represent all the column except the dependent variables. Okay. Fine, Madhu. Sure, Suhas. I'll try. Okay. So regression we'll see at the last. Okay. I'll give you samples of regression. So plot of tree, is it a formula? Fine. So plot of tree is not a formula, it is to visually represent it. Fine, Madhu? This all for visual representation or for our inference, that's all. The main thing is like this code and this code. 45th line and 54th line is the important one. Fine. So practice it, definitely it will be easy for you. Okay. Clear, Madhu? Any queries on this? If you get what is doing, that's highly enough. Once you practice, you can get it.